Hi, greetings. Welcome to another video. Today we focus on interpreting graphs. So the graphs that are given to us in this schematic is a hyperbola defined by f of x, as well as a straight line graph defined by g of x. So we can just note that g of x is the straight line graph and f of x is the hyperbola. So we go on further to tell us the equation of the horizontal asymptote y is equals to +1. This is given by the dotted line here. And then they say the straight line graph G cuts the x-axis at B. So this here is the x-intercept for the straight line function. And the two graphs f and g intersect at A and B. So these are points of intersection, A and B. So the first question says write down the value 5.1.1, the value of q. And for the standard equation of hyperbola, f of x is equals to k over x plus q. We know that q represents the horizontal asymptote. So in this case, the horizontal asymptote is given to us as y is equals to 1. So therefore, we can just write that down. Q is equals to 1. Remember, Q represents two things. Q represents the horizontal asymptote, which is the line that the function approaches but never really cuts or touches. And it also represents the up and down shift of the graph. So you can see the hyperbola is shifted 1 unit up from the standard hyperbola. So the next question says determine the domain of f. So the domain is all the possible x values for which the function is defined. So that the hyperbola is defined for all values of x. X is an element of real numbers, with the exception that x cannot be equals to 0. Because at x is equals to 0, we have a vertical asymptote. And f of x is not defined when x is equals to 0. So the next question says determine the equation of the line of symmetry of f that has a negative gradient. So they want the equation of the line of symmetry for the hyperbola. We know that for a standard hyperbola where the y-axis and the x-axis are asymptotes, that the equation of the line of symmetry is y is equals to negative x. Remember, emphasis is given to a negative gradient in the question. But because now there is an upward shift of +1, so now the graph is shifted upwards by the horizontal asymptote y is equals to 1. It means the equation for the line of symmetry also gets shifted 1 unit upwards. So the equation for the new line of symmetry then becomes y is equals to negative x plus 1. Because remember, the graph, the hyperbola gets shifted 1 unit upwards. And if the hyperbola gets shifted 1 unit upwards, it means its line of symmetry also gets shifted 1 unit upwards, is defined by the equation of the asymptote y is equals to 1. So it means the equation of the line of symmetry would be, for f of x, would be y is equals to negative x plus 1. So the next question says determine the equation of the hyperbola. So we can start with a general form that was given to us. That is f of x is equals to k over x plus q. So we found q to be positive 1, so we can substitute k over x plus 1. So we need to find a way of finding the value of k. In order for us to do that, we need at least one point on f of x to find k. So we can actually find this point, x and y, for this point, because you will recall that point B is the x-intercept for G. So let's find the value of B here. If we can find x and y for B, then we can substitute it respectively to find the value of k. So to find B, we need to consider g of x. G of x is equals to x plus 2. So this is the x-intercept, so we let y equals to 0. So when y is equals to 0, we have x plus 2. Therefore, x should be equals to negative 2. So it means the coordinates of B is 2, negative 2, and 0. So it means the coordinates of B is negative 2 and 0. So now we can substitute these coordinates in f of x to find k. So when f of x is 0, it implies that x is negative 2 plus 1. So this is negative 1 is equals to k over negative 2. So therefore, k should be equals to positive 2. So now we can define f of x. F of x should be equals to 2 over x plus 1. So I'm just going to note it here. F of x here is equals to 2 over x plus 1. And finally, the last question, they want us to determine the coordinates of A, a point of intersection of f and g. So they're talking about this point. And this point, the point of intersection happens when the graph of f and g are equal. So they intersect when f of x is equals to g of x. So f of x is given as 2 over x plus 1, and g of x, we saw earlier on, is x plus 2. So we can multiply throughout with x. Doing so allows us to eliminate the x in the denominator on the left. It's equals to x squared plus 2x. So here and here x cancels out. So we have 2 plus x is equals to x squared plus 2x. So rearranging the equation, we get x squared plus 2x minus x minus 2 is equals to 0. X squared plus x minus 2 is equals to 0. So here we have a quadratic equation. We can form two factors, x and x. This has to be x plus 2 and x minus 1. We can test because the sum of these two gives us the coefficient positive 1, and the product of negative 1 and positive 2 gives us that. So it means these factors are correct. So therefore, x should be equals to positive 1 or x should be equals to negative 2. But remember, we are interested in A. The x coordinate of A is a positive value because it falls in the first quadrant. Point A falls in the first quadrant, so it means the x coordinate is positive. So it means we must consider x to be 1. And we can find the corresponding y value by substituting it in either of the equations. So I'm going to just use g of x because it's more simpler. So g of positive 1 should be equals to 1 plus 2, 1 plus 2, which is equals to 3. So it means the coordinates of A is 1 and positive 3. So we can just note it here. A should be equals to 1 and 3. Thanks for watching. See you in the next one.